All right, let's have a look at how we calculate the equilibrium constant from a given question. Firstly, here is a chemical equilibrium system that I'm checking for its states. I have aqueous, aqueous, and aqueous, so all three species need to go into the K expression. I'm then told that at equilibrium, I have the following concentrations: 0.92 molar, 1.62 times 10 to the minus 2 molar, and I've got 1.02 times 10 to the minus 3 moles per litre. So I'm checking they're all given as moles per litre, which they must be, and all three of them have concentrations that I can put into the K expression. So the first step is I have to construct my KEQ expression. So KEQ is equal to the concentration of the products, this one and this one, multiplied CH3COO minus times H plus. There's my products, they go on top. I divide them through by my reactant concentration, which is acetic acid, CH3COOH. There's my K expression. In my experience, students always want to skip this to go straight to the numbers. Don't do that to start with, because the check you've got to make is, do I have any coefficients that I need to raise my concentrations to, because that's where errors are made. In this example, I don't. All of these have a hidden coefficient of 1, so I'm really raising each of these to the power of 1, which means nothing changes. So I've done the check, I'm right to substitute my figures in to my K expression. Now, the concentration of acetate that's given is here, 1.62 times 10 to the minus 2. So I can put that straight in. That's the concentration of acetate at equilibrium. Concentration of hydrogen ions, which is stated in the question, is over here, 1.02 times 10 to the minus 3. I'll put that in, and I'm going to divide that through by the concentration of my reactant molecule, acetic acid, that I'm told was 0.92 moles per litre. Now that I've got my K expression with my numerical values in moles per litre, I'm ready to put it into my calculator. So you just go ahead and calculate 1 times 10 to the minus 2, close those brackets, times 1.02 times 10 to the minus 3, close those brackets, divide it through by 0.92 equals. I now have 1.796 times 10 to the minus, struggling to keep the paper steady, minus 1, 2, 3, 4, 5 times 10 to the minus 5. Sorry about the messy writing and the blurry video. Come on, iPhone. And then I'm just going to check my sig fig. I've got 3 sig fig, 2 sig fig, 3 sig fig. So my answer should be 2. So it's going to be 1.80 times 10 to the minus 5. 1.80 times 10 to the minus 5. Now, there are no units for K expressions. That is a ratio number which tells us the mathematical relationship between the relative concentration of the products versus the relative concentration of the reactants. The fact that this number is quite small, have a look at it as it's displayed on the screen, that's a small number, this is a small number. That means that the position of equilibrium, Le Chatelier, for this particular reaction sits well to the left, meaning there's far more reactant than there is product. The smaller the number, the further left it is. The closer the number is to 1, the more in the middle it is, because of course something divided by itself gives about 1, meaning relative concentrations are equal, or if the number is very big, it means that I've favoured the forward reaction. So this number being quite small means that this equilibrium sits fairly well left.